la 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 la. In this Unity tutorial, I'm going to visualize audio. So I have made a project to show a demonstration, and you can look at it and see how I did it, and do things with it for yourself. So here I have a project, and if I press play, I will see a song. The spectrum data of the song is being displayed with these cubes over here. So it's really kind of simple. I just made an empty game object over here and I named it visualization. And then I drag and drop one of these audio sources on it. The current one there is 5, but I could change it to whatever song I want. So I have an audio source component I added. And then I added my visualize script. My visualize script takes the cube scale to say how big the cubes are going to be. And then, with the sound as it increases and decreases on each frequency range. And then how many samples I'm taking from the audio, per interval of time, every time the update function hits. So the visualize function, the visualize script looks like this. It has 2 jobs. It's going to create the cubes on the game screen, and it's going to size the cubes after it reads the sampling data from the audio. So here are my 2 public variables in the inspector that you saw. I need a pointer to the audio source since I'm going to be dealing with the audio, and then I have 2 arrays. The samples array is going to read the sample spectrum data from the audio source every update call, and the cubes array is going to take that sample data, the values of it at each sample, and size the corresponding cube. So here in the start function, I get a pointer to my audio source, and then I allocate my sample and cubes array to be the size of however many samples the person said they wanted in the inspector window. And then I made a function separate it off to create the cubes. So when I create the cubes, I create 1 cube for each sample. See, so the loop goes up to num samples. And I create a primitive game object, a cube, and I position it along the x-axis so that they're all side by side going along the x-axis. Then after I make that object, I just add it to my array, my cubes array. Okay, so that is taking care of my initialization in the start function. Now in the update function, which happens, every frame of the game, I first get the samples and then I show the samples. So get samples is simple. I probably didn't even have to make a function for it, but what it does is it uses the audio source and it uses the getSpectrumData function. I feed it the samples array, and however big the samples array is that I feed it in, that's how many samples it's going to fill in to give back to me. And then for the channel, I say 0. And for the FFT window, there's a couple of choices. I just picked the first one because I don't even know what the other ones do really. So I just picked the first one, Blackman. All right, so there's one thing, getSpectrumData is a deprecated function, I realized after I did this tutorial. So I'll probably look up the function that is not deprecated after this and do another one with the not deprecated one. And the samples, the lowest samples that you could feed in is 64 for the array size. And then I think the highest, I don't know, 20K or something like that. I'm not sure. But it's on the details for the getSpectrumData function. So that fills in the samples array. Then in the update function after that, I say show samples. So that's pretty easy too. I just loop through all my cubes, which there's the same amount of cubes as samples. And I calculate a value to scale the cube. I use the cube scaling that the user provided, and I gave, I think, a number of 300 times the sample. And the samples are, they're sometimes decimal values. They're very small values, but they're decimal. Maybe they do get greater than 1. I'm not sure. But they're small numbers. And so I multiply by cube scale so I could see the cube actually get big enough. And then I take the cube at I and I scale it. I leave X alone and I scale it on the Y and I scale it a little bit on the Z just to emphasize the change in size more. So that is the script. And let's see, song number 1, let's see what that looks like. A lot of times for music, like the here is where most of the spectrum energy is in the lower end, and it's hard to get up here in the higher end. I mean, that's like ear-pitching sounds that kind of would break my eardrums. But here's another song, and you can see this song has some higher pitched sounds in it, and they're up here, going further along in the axis to the higher frequencies. And then I have a third song. I just like kind of looked at a couple of songs online. And where did I go online to get my music? You can go anywhere, but I kind of went to freesound.org. And there I kind of signed up for a membership with my email. It's free. And then I could just do a search for things I want, like songs. And you know, here I come back with a bunch of sounds. And if I want to see what the sound is, let me just stop this. If I want to see what the sound is, I could press play. Okay, or maybe this one better. And then literally just download the sound after that. So let me download this one, this beat thing. And I'll just bring it to my desktop first, save. And now I just got a sound, any sound, and I just drag and drop it. Oh, you just see it that it kind of saved to my desktop right there. So now I'll just drag and drop it into my game. And I could put that on as the audio source. And let's see what that sound that I just randomly grabbed from the internet looks like. And basically that's what this does. I think this one here is a bird. Let's see what that looks like. A bird is higher pitched sounds. And let's see what this one looks like. Number 5. Woo! And number 6. Like a sci-fi beat. So anyway, that's my tutorial. If you need the script, you can get it from omarvision.com. Search the tutorials and search audio for the tutorial videos, and the script will be there with it. Hey, thanks. Have a great day.